now some spectacular.
Spectacular. There's something to live up to.
Turn this one on.
Miss, have you even turned the gas taps on?
Yes.
That's good. Put it on, oh, it's on safety film already.
Okay. Right, welcome to science. We're going to do a few demonstrations. So, before we start, remember, science is very unpredictable. So sometimes it works amazingly and sometimes it doesn't. So fingers crossed today they're all going to be super spectacular. And I'm going to get lots of oohs and ahs from you. Is that right, guys? Lots of oohs and ahs. So I'm going to put my safety protection on. I've got my lab coat on already. I'm going to put... Oh dear. That's the gas.
We run out of gas.
There is a fault on the gas.
Do you want me to go get Miss Chacon?
Yes, if we can get another teacher, we'll sort that out. Doesn't matter. We can get on with the other ones without the gas. We'll turn it off.
They run out, they didn't pay the bill.
We don't need it for the first one. So the first one, guys, is called Genie in a Bottle. Okay, we're using hydrogen peroxide in the bottom of this conical flask. Hydrogen peroxide is the kind of chemical, a bit like what mums might dye the hair with, but we wouldn't use this one because your hair would fall out if you put this strength on your hair. So we've got a compound in there called manganese 4 oxide, and that's going to act like a catalyst to oxidise the hydrogen peroxide. Hopefully that's going to produce lots of water, which is going to come off as steam because it's very, very hot. So it should look a little bit like the genie coming out of the bottle. Let's hope so. So, put my glasses on. So can we all see the bottle?
Yeah.
Yeah? Here we go. Yes, thanks for the ooh. It's like a bubbling potion. We're starting off small, guys. We're getting bigger, don't worry. But I think that's pretty impressive. I think that deserves a bit of a round of applause. Okay, so you can keep your eyes on the like steam on the bottom. So you can keep your eyes on that while we have a look at this one. Now, this is one of my favourites. This is called the whoosh bottle. Now, at the end, I want you to tell me why it's called whoosh. You can have a guess, can't you, why it's called the whoosh bottle? So it's a big water bottle. So what I'm going to do is I am going to put some, this is called propan-2-ol. It's an alcohol, and we're going to use this because alcohols burn very easily. So we're going to show you a combustion practical. So I'm going to measure this out carefully. Okay, so this is my alcohol. I'm going to pour it into a beaker. I'm going to pour this into the whoosh bottle. Now, what I now want to do is shake this bottle about and get the alcohol mixing with the air inside. So it's going to coat the bottle. Oh, this is my exercise for the day. Mix it around so it's coating, it's mixing with the air. Hopefully, that should all be in there. I'm going to just pour out any excess if there is any. Nope, we've done a good job. Okay. I'm now going to light it. And we'll see what happens. So make sure you can all see the bottle. We ready? Why is it called the whoosh bottle? Well done. Okay, so that's a combustion practical there, and we can see that it's all gone a little bit black. So inside of that, it has produced two products. You've got the carbon, which is the black you can see. If I show you another beaker, it's also produced some water. Ta-da! That's one of my favourites. So that's the whoosh bottle.
Do it again.
We were going to do the thermite. I don't think I'm going to be able to do that without the without the Bunsen burner, because I don't think the magnesium will light. So we might have to leave that one, guys. So we will go on to the coffee whitener flame. Don't worry, we've got contingency plans. So, coffee whitener flames. Simple coffee whitener, or any other make will do, so long as it's not diet. We want full fat coffee whitener. So this demonstration is to show the fact of particle size. So if I try to light with my matches, which are over there, if I try and light that coffee whitener with a match, it's not going to set fire. It's not going to catch fire. But if I sprinkle the coffee whitener and separate the particles greatly over a flame, then it is going to catch fire and you might see something quite spectacular. So let's have a see. I'm going to light these splints. Not that.
We should use all your matches.
That's going to protect you. That's going to protect me. Okay. As we sprinkle.
That hot.
I wanted a better ooh than that, guys. We ready? So we're also showing here how much energy there is in food. Look at the huge flame and the heat that's coming off that. Woo. And you might be able to smell that sweet smell of burning sugar.
Dip it all on me. I'm looking down. I'm not too bad.
Woo.
You'll burn all that.
One last bit.
Bit more.
Well done. Okay.
Set fire to the thing then.
Oh. So is the gas definitely not going
Make it
back on?
sharper. Make.
Yes?
You can set your Sharpie on fire.
Oh.
Oh, we have to open the window for this.
Oh.
Oh, shut the window maybe.
Is it proved? Yeah? Right, what I'll do is I'll get the rest of it mixed together. So, this is a displacement reaction. So we're going to make molten iron from these powders that are on here. So, when you come to high school, you're going to learn about displacement reactions of some metals being more reactive than other metals and displacing them out of a compound. So we've got iron oxide here, and we've got aluminium powder. So the aluminium is more reactive, and it's going to take the iron out of the iron oxide, and we're going to produce molten iron. We're going to drop into this boat over here. Okay? So, that is the plan. This is the same process, by the way, that they use to make railway lines in situ. Exactly the same process. So I'm going to mix these two powders because I want you to see that it's just a powder to start with, but we're going to get a lump of iron at the end, hopefully.
Don't you need to mix them?
No. Want to come and do it?
Yeah.
Okay, so I'm going to mix these up well. So I'm just pouring it from one to the other. So we can say that it is all mixed. I'm going to pour that into the filter paper. Okay, so what I've got here is a starter mixture. So we've got magnesium powder and barium oxide. This is actually classed as an explosive. If I had more of that, I would need a license to have explosives and it would be illegal, so better not get any more than that. So I'm going to make a little well at the top of it, and I'm going to put the starter potion in there. This should start the explosion. And then I'm going to take this, which is a piece of magnesium, and that's going to be like my fuse. So I'm going to light the magnesium, and as that burns down, it's going to start, hopefully, the reaction. So we put that in. So So I'm going to get these screens up. Now when I set fire to the magnesium, it's a very, very bright light, guys. So don't look directly at the flame.
We've said that.
Okay, are we all right to turn the gas on, Miss?
Yes, that's fine. Miss, do you want the lights off or do you leave them on?
I think it'll probably be bright enough, but you can if you want.
Lights
So
off.
what we're looking for, guys, is going to be very bright light as it burns. As the magnesium goes down, there should be a big explosion and the molten iron should drop from that pouch into the water. So, that's what should happen. Come on, light. There we go.
I can look at it.
So, that's pretty spectacular, but has it made iron? Has it? What I've got here is a magnet. It's a magnetic stirrer. So it's a magnet on the end of a long pole. I'm going to see if I've got... Oh! And we've got lead on the end of it. Can you see?
And that deserves a round of applause.
Okay, so do we think we've got time for one more?
Yeah.
Right, guys, this didn't work this morning, so we need our fingers crossed for this one. Because science is unpredictable. Sometimes the reactions are more vigorous than we think. Sometimes they're a bit less vigorous than we're expecting. So we'll have a go, and we will see. This is called cannon fire. So if it works correctly, it should be really loud, and it should sound like lots of cannons shooting and firing off. Okay, so I've got an evaporating basin here. I'm going to use that old faithful thing, the hydrogen peroxide, that we used before. Put that in. Okay. So we've measured the right amount of hydrogen peroxide, and that's going in the basin. Okay, we're then going to put some ethanol in. And ethanol is just so that we can get a flame to burn. So, I'm going to put my ethanol in. Now, I'm going to set fire to the ethanol. But obviously, I'm going to light it from a distance. Okay. Not going to go out. So hopefully we should see the flame. Oh, I've wet my screen. We've got another one. Oh. Alright. Is it lit? Yes. Is it lit? I'm not sure it is actually. Let's try it. Let's add just a touch more ethanol. I don't think it was lit. Okay. Please ethanol light. Is it lit? Yes. Okay, that wasn't the spectacular bit, don't worry. This is the spectacular bit. Hopefully. That went better. And that's our demonstrations for today, guys.